Hello and welcome to a video on rational and irrational numbers. And in this video we're going to look at what they are. So we're going to define them, and we're also going to look at some numbers and categorize them as either rational or irrational. So first of all, what do we mean by rational and irrational numbers? Well, if we just think about the general usage of the word rational, I could say that I've got a perfectly rational explanation for going to the shops. So I'm not going to go to the shops just because I feel like it. Maybe I've run out of food or I need to do my weekly food shop. But there is a perfectly good reason for me going to the shops. There's a rational explanation. Now in maths, it has a very specific usage. So if we think about the first 5 letters of the word rational, you can see that we have the word ratio. So a rational number is just a number that can be expressed as the ratio of 2 integers. So as long as we can express a number as the ratio of 2 integers, or a fraction where the numerator and the denominator are both integers, then we have a rational number. And if you're a bit unsure about what the word integer means, well, an integer is just a positive or negative whole number, which can also include 0. So now I'm going to list a bunch of numbers, and we're going to go through each of those numbers and categorize them as either rational or irrational. So if we look at the first one, 4, that is clearly a rational number because that can be expressed as the ratio of 2 integers. So we could say that 4 is the same as 4 over 1. 4 divided by 1 is 4. Or we could say 8 over 2. Or we could get quite fancy and we could say negative 40 over negative 10. That will still give us a value of 4. So as long as a and b are both integers, then we have a rational number. And remember, an integer is a positive or negative whole number or 0. So here we've got negative numbers, but they are still integers. So 4 is a rational number. So let's just write that above here. Okay, if we look at negative 3, again, we can express this as the ratio of 2 integers. We could say that negative 3 is the same as negative 3 over 1. Or we could say 300 over negative 100. Both of these will give us a value of negative 3. So 3 is also a rational number. And in fact, there are an infinite number of ways that we can express a rational number. So this one here, 5/6, well, that is also clearly a rational number, and it's already expressed as the ratio of 2 integers. Now, if we think about the square root of 2, well, if I type in the square root of 2 into my calculator, it gives me a value of 1.4142136562, but that number actually goes on forever. Okay, this number will never repeat itself, and it will just keep going on and on and on and on and on and on and on forever. And whenever you see a number like this that just keeps going on and on, this can never be represented as the ratio of 2 integers. So the square root of 2 is irrational. The square root of 2 is irrational. And actually, the square root of any non-perfect square will always be irrational. And what I mean by a non-perfect square is any number where when you take the square root of that number, you do not get a nice integer. So for example, if we were to take the square root of 100, or the positive square root of 100, well, that will give us 10. So 100 is a perfect square. So the square root of any non-perfect square will always give you an irrational number. So now if we look at the next one, the positive square root of 49, well, if we take the positive square root of 49, we get 7. And we know that 7 is a rational number, so the square root of 49 is a rational number. Okay, the next one, 0.3, and we've got a little dot above the 3. And what that dot means is that's just the symbol for recurring. So this is the same as 0.33333, and actually that 3 will keep repeating on forever. Now, if we were to convert this into a fraction, 0.3 recurring is exactly the same as 1/3. So although we've got a number that keeps going on forever, this can be expressed as a fraction where the numerator and the denominator are both integers. So again, we have a rational number here. And in fact, any number that has a decimal that keeps repeating on and on forever, that will always be rational. And I'm not going to go through that now, but in a future video, I'll explain why that is the case. Okay, the next number is pi. That is the symbol for pi. And when I type pi into a calculator, we get 3.141592654. And actually, again, that goes on forever. It goes on and on and on and just keeps going on forever. So just like the square root of 2, pi is also an irrational number because it is a decimal that just keeps going on and on forever and it never repeats. So pi is an irrational number. Now the last one, 0.743, and we've got a dot above the 7 and the 3. So what that means is this is 0.743, 743, 743, 743, and that 743 pattern keeps going on and on forever. So everything between the two dots just keeps repeating. And we said before, whenever we've got a decimal that repeats, has a pattern that repeats, that will always be rational. So although it doesn't look like we can express this as a fraction, we can express it as a fraction, and that's what we're going to look at in a future video. So if we were to write this as a fraction, it would be 743 out of 999. So we can clearly see that it is a rational number. So hopefully this was a nice introduction to rational and irrational numbers. And the easy way to remember this is that if we've got a decimal that keeps going on and on forever and never repeats, then it's always going to be irrational. So just like you've got pi, or the square root of 2, or the square root of any non-perfect square, they will always be irrational. Whereas if we've got a decimal that does repeat, like these two here, then we can always convert these into fractions, where the numerator and the denominator are both integers. So repeating decimals will always be rational. And this conversion of a recurring decimal into a fraction, that's something that we're going to look at in a future video. I'll see you soon.